Okay, we got the 2020 spec exam, our last 4 exams that we'll be doing. So let's go. Time is on, 50 minutes. Evaluate exactly for cosine squared of x minus sine of x. So we know that cosine of 2x is equal to cosine squared of x minus sine squared of x. So that cosine of 2x is equal to, oh sorry, no, this is actually equal to let's say 1 minus 2 sine squared of x. Does that help me? Sorry, wait, no, I want the cosine squared of x. So cosine squared of x, so 2 cosine squared of x minus 1. Then, so cosine squared of x is going to be cosine of 2x plus 1 all over 2. So then this integral equal to pi from 0 of 2 cosine of 2x plus 2 minus sine of x dx. And this is going to equal, we have the 2 there, it's going to be sine, so sine of 2x plus 2x plus cosine of x from pi to 0. Sine of pi is going to be 0 plus 2 pi minus 1 minus sine of 0 is 0, 0 plus 1. So it's going to be 2 pi minus 2. Alright. Determine the normal vector n for plane. So we'll say that the normal vector is just going to be the cross product of 3, 0, 1 times 1, negative 1, 2. Starting from the top, it's going to be 2 minus 1, so 1. The middle is going to be 1 minus 6, so 5. And the bottom is going to be negative 3 minus 0, so negative 3. Make sure I got that right. That's my formula page. A2, B3, and then B3, A3, B2, A3, B1, A1, so it's 1, minus 6, B3, and A1, B2, so negative 3, minus A2, B1. Yep. Determine the Cartesian equation for the plane. So let's say that R dot 1, negative 5, 3, negative 3 is equal to 0, 0, 4 dot 1, negative 5, negative 3. So then we have that x, actually we'll just evaluate this first. It's equal to negative 12. So then x minus 5y minus 3z equals negative 12. The graph of that, the defining rule is that. Determine all of these. Okay. So our vertical asymptotes are at C and D. So let's say D is 3. D can be 3. And then C will just be 1 because it's plus. Alright. And then x squared minus b will be at 0 points. X squared minus b. So negative 2 and 2. So b is 4. Equals x squared. So 2 squared minus b is 0. Yep. And then where's a nice point? Let's take this 6, 6, 3, 6, 3. So then 3 is equal to a side of x squared, which is 36, minus 4 outside of x plus c. So 6 plus 1 is going to be 7. And x minus d. So 6 minus 3 is 3. So 3 is equal to 32a on 21. So a is going to be equal to 63 on 32. That seems like a very odd number. That seems very, very odd. So when x is 0, x is 0, that's going to be negative 4a. So 62, or 63 and 32. All over c, which is 1 and 3. I think it's probably alright. This is 3. 63 and 32. X squared, and then we have x plus 1, x minus 3, 21. Yeah, it must be it. Alright. Consider the equations. We'll explain whether or not any of these planes are parallel. So we'll just talk about the normals to each of these planes. The normal to 1. Is 1, 1, 1. Plane 2 is 1, -1, -1. And then plane 3 is 0, 1, 1. As none of the normals are parallel. Normals to the planes. The planes themselves are not parallel. Okay, solve the system, or solve the given system of simultaneous equations. So let's just do plane 1. Let's just write it all out. I don't think for this one we need to do the matrix version, the augmented matrix, because this seems really, really easy to solve. 7, and then y plus z is equal to 1, and this should be a minus here. So let's say this is 1, 2, 3. So we can just do 2 plus 3. Right, x is equal to 8. Therefore, wait, no, x is equal to 3. Wait a minute. Plus 7 is equal to 1. What the heck? Wait, do we have to do augmented matrix? I don't think so. Because that's x plus minus y minus z plus y plus z plus 1. X is equal to 8. And now I'm confused, guys. say x plus 1 equals 4, so then x here equals 3. If x of there equals 3, okay, I think I will have to do this with some augmented matrix or whatever. So let's go 1, 1, 1, 4, 1, negative 1, negative 1, 7, 0, 1, 1, 1. So let's do row 2 minus row 1. Should be 1, 1, 1, 4, 0, negative 2, negative 2, 3, and then 0, 1, 1, 1. Clearly, this is not going to work out. And then we'll do row 2 plus 2 row 1 for 0, 0, 0, 5, 0, 1, 1, 1. No unique solution. These planes are parallel. So 4 x minus y minus z is 7, 1. Let z equal lambda, then y is equal to 1 minus lambda. X minus 1 plus lambda minus lambda is equal to 7. So we'll say x is equal to 8. Then x plus 1 minus lambda plus lambda is equal to 4, is equal to 3. No unique solution. Minus 0. No unique solution. There's no solution at all. If there's 0 solution, why is it that they are not parallel? 1, 1. So row 2 minus row 1. Minus 1 minus 1. 3. Add 2 of each. Yeah, I don't know. Okay. Determine the geometric interpretation of the solution for this system of equations. Yeah, because here I get that x plus 1 equals 4. X minus 1 is equal to 8. Skew might be skew. Skew planes with no common intersection. 3. I think so. Let's say 2 skew planes with another cutting through the 2, but with no 3. So it could be something like plane 1, plane 2, plane 3, 1, plane 2, plane 3. Okay, that was funky. The graph of that is shown below. Let's sketch the graph of one over f of x. So we have our 1 point there, and this will be vertical asymptote all the way down, and another one. Wait, hold on, pause, I fully put my timers on. And we are back. Also, I just realized that I should be doing the 2019 spec exam, not the 2020, but oh well, it's fine. And then, oh wait, sorry, not a -2, it should be a -3. -3, we're gonna have u like this. And then -1 will be at -5, and then again at 3. And this should be at 1, not at 2. Alright, so it's gonna look something like this. Minimum point there. Where does it intercept? Half. So I'm doing like 2. That, boom. And it's a half at -4, -2 there. And then half at 2, so -2 there. Being boom, and then here, being boom. Alright. Hence, give the domain and range of x of that. So this is 2 minus x plus 1 all over 2. What's the range of 4? Okay, so h of x is equal to 2 on f of x. So let's just do the domain first. X is a part of the real such that cannot be x is greater than x cannot equal just -3 or 1. Yeah. X cannot equal -3, and x cannot equal 1. And then range, it'll be double the range of the normal one. So y is a part of the real such that y must be greater than or equal to 2, or y is less than or equal to 0. Or y is less than 0. Because it can equal 2, it can't equal 0. Alright. Page 10. How many questions are there? 13. Okay. So we are up to 10. Consider f of x is equal to that, which happens to be inverse tangent determine the defining rule for yg of x. Well, then we want that x is equal to 2 tangent of y. So then y is going to be equal to tangent negative 1 on x on 2. Given that 2, do I have to do the range and stuff? Negative time 2. Well, I think the range is infinite. Well, x is infinite. I mean, domain is infinite. X can be any real number. Given that x is a part of the real, I'm going to do like this. X is a part of the real, and I think that's legit. Zero negative pi on 2. So that's negative pi on 2 to pi. And it's negative pi on 2. So negative 1 on 0. And then, yeah, okay. By using implicit differentiation, show that g dash can be written in the form a x squared plus b wait, inverse implicit differentiation of an inverse tangent of x. Is there another way to do, so let's say x is equal to, I don't know, 2 sine of y or cosine of y. It would just be the inverse tan of x, right? Inverse function of f of x. What? So x is equal to 2 sine of y cosine of y, and I want to isolate y. So let's say cosine of y over sine of y equal to 2 on x. This is cot of y is equal to 2x. I don't get this, chat. I am not getting it. By using implicit differentiation, wait, For y equals g of x. I'm actually so lost right now. Inverse tangent a plus b. Inverse function of f. Is it not just inverse of tan? What if I say let u equal tangent negative 1 of x on 2? Tan x on 2. No. Tangent. I think I'm going to skip this for now. Okay. Hence the term of value, so then we need this to be 3x squared plus 2x plus 6 is going to equal q of x minus 3 plus r of x squared plus 4. At x equals 3, that's going to be 3 times 9, so 27. 6 plus 6 is going to equal r, or 13r. So this on the left hand side is 39. 13r, so r is equal to 3. R is equal to 3, q is equal to 3q plus 12, 6q is equal to 2. If we tell that is 3x squared plus 2x plus 6 all over x squared plus 4, and then x minus 3 equal to 2 on x squared plus 4 plus 3 on x minus 3. Okay, and then I have to evaluate that, and it's the exact same. This is 2 on x squared plus 4 plus 3 on x minus 3 dx. How do I actually differentiate the first one, x squared? Oh, okay. Plus 4. It's going to be this. G of x is going to be tan negative 1 of x. So 2 plus ln, or 3 ln, of x minus 3 plus c. How do I show that? I can get that from here. if I just take the cosine of y and sine of y equals 2 on x. So if I differentiate both sides, cot of x. So this is going to be cosine of y. Derivative of the top is going to be negative sine of y, sine of y, minus derivative of the bottom. It's going to be cosine of y, cosine of y, and on the bottom it's just going to be sine squared of y. This is going to be equal to, so let's say d dx. Oh wait, no, to do the top, I'm going to have a dy dx here. Minus, and then this will be cosine of y, cosine of y, dy dx. Bottom, square this, and then this will equal negative 2 on x squared. Now this is going to be negative cosine squared of y plus sine squared of y, negative dy dx, all over sine squared of y, negative 2x squared, so it's going to be, that becomes that, so negative dy dx all over sine squared of y is equal to negative 2 on x squared, y dx, take away the negative, so equal to 2 on x squared. I feel like we're so close. And sine squared, 2 sine squared of y. I think this is it. If I just stay with 2 equals tan of y, so 1 is going to equal 2 secant squared of y dx. That doesn't help, does it? -1. This one whole square not exactly sure where it's going. And then this one, I assume this was just from part B up here, but I don't know how. Now whatever, we're just gonna move on. So using this substitution, then another du dx, it's going to equal a half of 1 on 2 square root of x plus 2. Then when x is equal to 7, u is going to be equal to 3, u is equal to -1, u is going to be equal to 1, when x is equal to -1. And then, 4, have that. And then I also want that u squared minus 2 is equal to x. Okay, so I have -1, so 1 to 3 of 3u squared minus 6 all over, and I want to get half, so I'm going to multiply everything by 2 on the outside, so 2 square root of x minus x plus 2 dx. So this is going to be 6, 3, 1, u squared minus 2 of du. So this will be 6 of u to the power of 3 all over 3 minus 2u from 3 to 1. So this is 6 of u from 3, so 9 minus 6 minus 1 of 3 minus 2. So this is 6 of 3 minus 6 on 3 minus negative minus negative 5 on 3. So this is 18 plus 10, so it'll be 28. Plus 3 will be 14. Yeah, it's 28. Here, consider the sum equals I and 1 is 20i expressed by the sum from r cis theta. So I squared is -1, I3 is equal to -I, and then I4 equal to 1. Cis theta. This I have -2i, plus 5 minus 7 minus 4. So the sum of 2020 n of I to the n is equal to, so every half or every second one here, I'm adding 1 or adding I, but then I'm taking away 3i, then I'll add 5i, then I'll take minus 7i. And since there'll be 1010 of them because it happens every second, there's 1010 of these like pairings, so 1010 of -2i, then what happens with the I squared? So here I'm -2, but then I'm like +4. So again, every 2 I'm adding 2, so it's going to be equal to 2020 of 1 minus I. So will it just be 2020 cis of prime 4? Negative prime 4. Maybe? Now 2020 square root of 2 cis of negative pi on 4. I believe so. I actually think I might be onto that. Pretty happy with that one. I want to go back to this one though. I'm so confused on how you need to do this. We're using implicit differentiation. So the g of x can be written in the form. So is my defining rule for y equals g of x is wrong. The derivative of tangent negative 1 of x on 2. I don't think there's like a formula page anywhere. Inverse tangent. X is equal to 2 tangent of y. G dash of x. Tangent negative 1 of x on 2. Okay, it says implicit differentiation, so there's probably a y somewhere. Let's just do x on 2 equals sine of y over cosine of y. Then let's say that x squared on 2 equal to the top is cosine of y dy dx minus the bottoms are plus sine squared of y dy dx all over cosine squared of y. Then this is going to be dy dx plus 1. Okay, wait a minute. What if I do cosine squared of y plus sine squared of y all over cosine squared of y. Because then I get that this is equal to dy dx of 1 plus tangent squared of y so dy dx is equal to x squared on 2 plus 1 plus tangent squared of y is, isn't that like secant squared or something? Secant squared of x. It's 2 secant squared. Why though? Not happening. Oh, sorry, not that. X. And the top is negative sine, so negative sine squared of y dy dx minus cosine squared of y dy dx on sine squared of y. It's going to negative 2 on x squared. So now let's do sine squared of y dy dx plus cosine squared of y dy dx. So y is going to equal 2 on x squared. Then this becomes 1 plus cot squared of y dy dx is equal to 2 on x squared. Now cot squared of x is going to be equal to sine so 1 minus cot of x equal to cosecant. So this is equal to cosecant squared of y dy dx. Oh, I feel like I'm so close. So you get 2 on x squared x squared cosecant. Right now. Okay, well, we ran out of time. It's unfortunate. Yeah, I'm very lost in this question. Oh, it is what it is. So I'm going to get to calculator soon, and we'll get started on that. Okay, we got calculator assumed. Let's go. The small shape of the shape of a small wine glass is modeled by a revolving curve sign. Not the x-axis. All dimensions are in centimeters. The depth of the wine glass will contain 80% of its maximum volume. Maximum volume. How am I even meant to find maximum volume? So let's say y on pi equals x minus 3. Then y is equal to pi inverse sine of x minus 3. Can I even do that? So volume is equal to... Oh wait, no, we're rotating about the y-axis. About the y-axis, I need to be about the y. F of x. Sine of y pi plus 3 for x. So then I'm going from 0 to 6 of sine of y on pi plus 3 squared dy equal to 0 to 6 of sine plus 3 squared. So I need pi up front. At least my calculator's been radians as well. The depth of the wine in the glass. Come on. It's taking a little while to solve, so I'm going to do this one. Oh no, never mind. And I probably did not want that to be a standard. What is this in decimal? 259.53. Therefore 80% of volume is equal to 0.8 times 259.53. So 207.624. If I want to solve for 207.624, it's going to equal 0 or pi to some value k of sine of y on pi plus 3 squared dy equal k. Cast k is equal to boom, and then bing, boom. But wrong argument type. Y. Okay, and that's going to solve slowly. Sketch of the locus has been shown. Write equations and inequalities without for the indicated locus. Wait, there's a dot there though? What? Okay, so it's a circle. So it's a magnitude of 1 minus 2i is less than or equal to 2, and the argument, so here this is 4.97, 4.96 centimeters. Okay, and the argument, the lower bound of the argument is going to be 0. So you got an argument of z from 1 minus 2i, and this must also be less than inverse tangent x minus 1 squared plus y minus 2 squared equals 4. And when x is 0, so it's just going to be 1 plus y minus 2 squared equals 4. So 1 minus 2 is the square root of 3. 2 plus square root of 3, so this must be equal to inverse tangent of so that length there is just 1, and then this one is 2, and that's square root of 3. So since that's a tangent of 1 over square root of 3, opposite over that is equal to pi on 6 plus 30 degrees must be less than or equal to pi on 2 plus pi on 6 it's going to be equal to 4 pi, so 2 pi on 3. Alright, so then 2 pi on 3. Sketch the locus of the point is equal to that. So this is z plus 2 minus z minus I. It's going to equal square root of 5. And then, but the distance from negative 2 to 1 is square root of 5. So I actually want the ray that connects these two. It's going to go out like that. Okay, because this distance here is square root of 5, so if I take like a point here, it's going to be this whole distance minus that distance, which obviously is equal to that, and so forth and so forth. Negative 2 and I, yep. Okay, let Z, W, and U be the complex numbers where, what the heck, determine the argument of U exactly. So argument of U, so U, what is Z? We don't have anything for Z. Oh no, we do. We have the conjugate of Z. So that's the argument of argument of 1 plus square I, so boom, am supposed to equal that. Therefore, and this is square root of 2 cis of pi on 4. Z dong. Argument of Z dong is going to equal so I need pi on 4 plus something to equal pi on 3. So x is going to equal 4 is pi on 12. So 3 pi on 12 plus pi on 12, yep. So the argument of z itself is going to be negative pi on 12. So then the argument of z over 2 minus 2I is going to be negative pi on 12 minus negative pi on 4. So it's going to be 3, so pi on 6. What are these questions, bro? These questions are horrid. Tell me the magnitude of u exactly. Okay, wait, so w is actually, we actually have enough information to form w. So w cis pi on 3. So then, magnitude of w is equal to 2. So then, I'll do this. Since cis of pi on 3 is equal to square root of 2 cis pi on 4. We'll do r cis of 3, so then r is equal to square root of 2, so the magnitude is equal to square root of 2, square root of 2, and the magnitude of u is equal to square root of 2 on 2 square root of 2, so it's going to be 1 on 2. Okay, God, I'm so happy that's over with. Okay, a cylindrical shaped tower has a path that spirals upwards from a point to an observation deck at point B, as shown in the diagram below. The path begins at point A on the ground and finishes at point B on the top. Let t equal time in seconds that the tourist takes. Has been walking along the spiral paths, 65 pi to reach P. Okay. Determine the height corrected in units meter at 0.01 meters. It's y and z. So there's 0.2. 65 pi is equal to 40.84 meters. Determine the torus velocity v of t. So then v of t is equal to d dt of x of t. So it's going to be negative sine 0.1 of t inside. This will just be cosine of 0.1 t. And this will just be 0.2. Show that the tourist walks at a constant speed and determine the speed correct to point on. Just a second. Magnitude is going to be equal to the square root of negative sine 0.1 t squared plus t squared cosine of 0.1 t squared plus 0.2 squared. And this is going to equal square root of sine squared of 0.1 t plus cosine squared of 0.1 t plus 0.04. So this is the square root of 1 plus 0.04 to 1.02 meters per second. Yep. Okay. Solve the equation giving exact solutions in the form. System of theta is equal to that. Okay, so z to the 4 is going to equal, I'm pretty sure that's going to be just 8. Square root of 8 squared plus 8 squared. No, it's going to be 16. 16 cis. Square root of 3 and 2. So pi 6. So then z is going to equal, zk is going to equal 2 cis of pi on 24 plus 2 pi k on 4. Given that k is going to be equal to 0, 1, 2, and 3. So z0 is going to be 2 cis of pi 24. Z1 is going to be pi 2, so 2 cis of 13 pi 24. 2 cis of negative pi 24, and then z3 is equal to 2 cis of negative 13 and 24. Okay, particle traveling in a straight line, so its velocity is that related by equation. Determine the acceleration in terms of displacement x. So acceleration is equal to v dv dx. So it's going to be negative 0.2x. Negative 0.2x times negative 0.2, so it's going to be negative 0.04x. Does the particles constitute simple harmonic motion? Justify my answer. A is equal to negative k squared of x. It would not, wait, would it? Is it negative? No, this does not. This form, as there is no k such that negative k squared is going to be 0.04. No real k. It is known that the initial displacement of the particle is determined correct to the nearest 0.01 second with a displacement of 2 centimeters. So we know that dx dt, which is our velocity, is equal to negative 0.2x. Why is this 2 marks? Why is this 2 marks? What the heck? So x dx is equal to negative 0.2 t dt. That is the dx. Okay, so this is going to be ln of x is equal to negative 0.2 t plus c. When t equals 0, x is equal to 4. So then c is equal to, so ln of 4 is equal to c. Therefore, ln of x is going to be equal to negative 0.2 t plus ln of 4. When x equals 2, ln of 2 on 4 is going to equal negative 0.2 t. Cast t is equal to, so ln 2 divided by 4 is going to equal 0.2x. 3.47 seconds. Okay, they ask cis of theta. How much do I have? 20 pages. We just got to halfway pretty much. I'll take any complex number such as that. Express in terms of r and theta, the complex number. Okay then, whatever. I guess this world hates me. So this is going to be equal to r cis of negative theta. My pen is doing the weird thing again. Negative theta all on negative 2 negative square root of 2 times square root of 2 cis of pi on 4. So I'm just going to be r on negative 2 negative pi on cis of pi on 4. So it's going to be negative r on 2 cis of pi on 4 minus theta. Wait, no. Of negative theta minus pi on 4. Okay. 11. Express argument of z minus ri in terms of theta, where a is equal to z minus r is r cis of theta minus r cis of pi on 2. I think that was a similar question to in the 2018 exam. So if we pull out a value of r, this is going to be cis of theta minus cis of pi on 2. Oh wait, no. I made the same mistake as what we did last time. Okay. So let's say we have some z, and this is a value of r. So this here is z, and this is r. Now ri is going to go straight down in the imaginary. So then here is z minus ri, and then this is r again. So this bad boy, now since I know that is theta, and this is theta, oh wait, no, it needs to be pi on 2 to pi. Okay. I'm not sure if that will change anything. Let's just redraw it though. I want nice and big so I can see what I'm doing. So this is z, this is r, and again, this is r, and this is z minus ri. And then these are the same. You know that this is theta. We don't know that that's theta, but that must be the same as this angle. So cis of theta. This here must be 2 pi minus theta. Since that must be 90, this is also 2 pi minus theta. And this here is x. So then x is going to be equal to pi on 2 minus 2 pi minus theta. So that's going to be theta minus 3 pi on 4. Okay. So in this value, let's call that one phi. Phi is going to be equal to pi minus theta, and then it's minus that, so plus 3 pi on 4 over 2. So then this is going to be 7 pi on 8 minus pi on 2. So then argument of z minus ri is going to be equal to, I'm not sure if we're getting this right, because I feel like 3 marks, I feel like there's a few too many steps, but this is going to be pi minus 7 pi on 8 plus pi on 2. So it'll be pi on 8 plus pi on 2. I feel like we might have done this in one of my classes ages ago. I feel like this might be right, but I'm not exactly sure. Oh, well, I can already see a mistake. That's not going to be 2 pi minus theta. This is just going to be pi minus theta. So here with that, minus pi. So that's just equal to negative pi on 2. Change that to pi on 2. 3 pi on 4. 2 minus 3.4. This used to be pi on 4 plus theta on 2. Okay, that's 12. Curve below is shown given by that. Calculate the area of the region that forms the interior of this curve. So it's just a circle with a radius of 1. Can I just do that? Well, how would they want me to do it properly? Say y is equal to square root of sine pi x on 2 plus 1. I can go from 0 to 2, taking away all of that. Area of half, it'll be symmetrical. Okay, let's do that. So y equals square root of sine of pi x on 2 plus 1. So then half of area is going to be from 0 to 2. Well, I should just do full area is going to be equal to 2 times square root of plus or minus. So 0 to 2 of the top function, so sine of pi x on 2 plus 1 dx minus 0 to 2 square root of sine. So do 1 minus square root sine of pi x on 2 dx. I wonder if they made it different from just a normal circle. Let's see. 0 to 2 square root sine of pi of x divided by 2 plus 1 dx minus 0 to 2 1 minus square root of sine of pi x divided by 2 dx. Make this lighter, make this nicer while that works through it. So again, this is 3.0510 unit squared. Let's do pi squared. Oh yeah, it is slightly different. They are trying to trick you. It's not just a perfect circle. answer, or the correct answer at least. 2. By using A to determine whether the curve is a circle, explain your answer. No. Area of circle. Radius of 1 be equal to 3.1416 units squared, which is not equal to the 3.0510 units squared. Which is actual area, therefore not a circle. Area. Not a circle. So yeah, it looks like they were trying to trick out some people that thought it would just be a circle like me. Okay, members of a random sample of N shoppers were asked by a consumer researcher how much they had spent in their shopping center that day. Let mu denote the mean and the amount spent. Standard deviation is known from previous research. 95% confidence interval is based on that. Mu based on the sample. Sample mean will just be $175. I'll just take a midpoint. Based on the confidence interval, calculate the standard deviation of the sample mean. Correct to that. 95%. So then margin of error is equal to 25. Sample mean. Based on confidence, we calculate standard deviation of the sample mean. Standard deviation would be mean square root of, so 175 square root calculate the standard deviation of the sample mean. Am I stupid? I don't get it. So I know that U is equal to 175. And that K is going to be equal to 1.96. And my margin of error is equal to 25. Calculate the standard deviation of the sample mean. So the sample mean for this sample. And my standard, so my margin of error is 25. Is equal to 1.96. Standard deviation is, oh wait, so my standard deviation will be that square root of n. Wait, no, it's not the mean. is it just going to be that? And since I don't know, so it's going to be like square root of n on square root of n. Maybe, so 25 divided by 1.96, 12.76. Wait, no. That's not right. Oh my god. I'm so stupid. This here is just like that, I think. Because s on square root of n is equal to that. Let's figure that out. Okay. So this is 12.56. Oh, sorry, no. 76. Standard deviation of the sample, yes. Because I'm looking at the statistical inference page on my formula sheet, and it's so confusing because z, yeah, okay, whatever. It's z times the standard deviation of the sample mean. The following week, the researcher again took a random sample of El shoppers from El Cheapo shopping center, but this time the sample size was doubled. What is the probability that the difference between mu and the sample mean from this will be less than $10? Okay, so then standard deviation. So sample size doubled. Then the margin of my standard deviation will get scaled by 1 on square root of 2. Therefore, that's x. Oh, actually, for mu will equal 175 still. That would be 1 on square root of 2 of 1.9. No. 12.76 should be 1 on square root of 2 of 12.76, so 9.02. Therefore, mu and the sample mean from the sample will be less than $10. So 165 to 185 of 9.02. Oh my god. And then my mean is 175, so that's equal to, so now CDF, 165 to 185 of 9.02 to 175. It's going to be 0.7324. It's the probability. The amount of chocolate that is placed into each biscuit produced by that has been observed to be normally distributed with that and that. So the probability the total amount of chocolate used for 50 biscuits is less than 365 grams. So let's just say that is going to be 1.5 square root of 50. 0.2121, so then let x, or let m, be approximately normal distribution with 7.5 and 2121 squared. We require probability of n being less than 365 on 50. Probability of n being less than 7.3 is equal to, so I want normal CDF of negative infinity to 7.3, so 2121, 7.5. So this is 0.1729. Is the probability that the mean amount of mass of the biscuit less than 0.2 determine the number of n that needs to be sampled. The mean amount of chocolate used per biscuit differs by mu less than that. So the probability that, oh yeah, I was talking to some people, they said that you probably shouldn't be writing the cast, you should be writing the probability statements. So okay. But let's say that negative, so I'm going to start writing probability statements. So negative k less than or equal to mu, less than or equal to k, or let's say z. Less than or equal to k is going to be 0.98. K would be, so solve normal CDF of negative x to x of 1 of 0 equals 0.98. So this needs to be 2.326 standard deviations away. So then 0.2. 6. Wait, what am I doing here? So 0. What am I doing? I can't think right now, guys. So then, since this is that many standard deviations away, then I need 1 point. So 1.5 over the square root of n. That doesn't make sense, does it? Oh. 98%. That's it. This isn't going to give me a proper answer. Less than 98% determine n, the number of biscuits that need to be sampled. Less than 0.2 grams. So 0.2 grams is now many standard deviations away. So 0.2 or 2.326. So the standard deviation. This is what I want, yes. So that gives me 0.085560. So this is the standard deviation in grams. So then 0.086 is equal to 1.5 square root of n. n is equal to 304.2. So then therefore at least different where the mean is less than if the probability of the mean of chocolate used per biscuit differed by less than 0.2 grams is, so I can just say, let's say roughly 3 or 4, because it doesn't say like minimum sample size or whatever. Okay, a competitor called Butte Chockies produce similar biscuits. Samples that representatives they will be using significantly more chocolate for each biscuit than Pickies are us. If you want the real chocolate tasted by for us, perform the necessary calculations to comment on Charlie's claim. Use in the sample, so then mean chocolate or mean mass is equal to 1090 all over 144, which is 7.5694 grams per. And then the standard deviation of the mass, which was 101.8. All over the square root of 144. 0.95. 95% confidence interval, k equals 1.96. Therefore, 1.96 times 0.15, so margin of error, 0.294. Therefore, we're going to have 7.59 or 5694 minus 0.294. 7.2754 less than or equal to mu, less than or equal to 7.8634. For this is for U and then for Bickies are us. 95% confidence interval will be, we have a standard deviation, so 0.2121 times 1.96, 2036, 7.5 minus 0.2036. So this is 7.2964 plus 7.7036. There's lots of overlap. In confidence intervals. Not enough evidence. To validate Charlie's claims. Not enough evidence to validate the claims. Alright. Oh, logistics measuring machine. Okay. Was modeled by the logistics equation of that. The graph of this model is shown below. This graph contains an inflection point at point L. Calculate the size of the sardine population at t equals 0.1. So when t is 0.1, we're going to have 2.4 over 1 plus 239, which is P, oh no, P of 0, 0.01, which will be in millions of tons, so it's be 10,000 tons of sardines. Rewrite the equation saying values of R and K, so then dP dt is equal to R and K. I've forgotten how to do this. R of P. So is R just 0.3 P outside of 2.4 minus P? K minus P. K minus 2.4. If I remember right, this bit here is like the limiting bit. So as it cuts closer to this value, we're gonna get a thingamabob. Wait, no. Wait, yes, I think. Only RK. Graph and see what happens. So 0.3x, that's a 2.4 minus x. So I should see a maximum. And it's 1.2. Yeah, okay. But is R just a negative 0.3? Here it says R negative RKT. Negative 0.3, negative R of 2.4. So 125. Hold on, I'm gonna get my formula page, my handwritten one that I've had a while ago. So I'll grab that. So I'll pause and be back. Alright, and we're back. So let's see. So it's the B and minus P. So my M is just 2.4. And my A, which was the 0.3 divided by 2.4. So 0.5 would just be B. Okay, cool. And the time of the environment is a technique of increments to calculate the approximate change in population in the next month. This is in years, so then change in population is going to equal dp dt, where s of t is equal to a 12th, and then at p equals 0.5 dp dt is going to equal, so 0.125 of 0.5 times 2.4 minus 0.5, 0.11875. This appear to be roughly 875 on the 12th. Times 1 divided by 12, 0.00990. Approximately 1,900 tons. Okay, determine the maximum rate of growth for the Saudi population, when n equals 0.2 dp dt is equal to 0.18, or approximately, approximately 180,000 tons per year. Alright, so we had the initial population was 1.3 million tons. So we're still doing that. Sketch a graph of the population growth in the axis below. Explain your graph. So past inflection point, and then here the P, past inflection point, so then on population growth slowing down. So rate of population growth is slowing down. So it will just be like this. Like that. Okay, wait, hold on. When did it reach 2.3? So when did it reach 2? Reach 2, like what is that? 24 maybe? Suppose the initial population of the sardines was that. So past inflection point. So already, so still limited to P max equals 2.4. There's no more inflection, but it will never reach above here. That's okay. 18. Consider the square AOACB, where point A is an origin. Let the position vectors for point A, B be defined at A respectively. Okay, let's define value. Okay, so value of. So O, okay, RC C and S to B. This means that the point position of the respective sides are equal proportion. Use the vector method to prove the size of PQR is equal to 90 degrees. So this angle. So if angle of PQR is equal to 90, then when I do the dot product of PQ and QR, P to Q dot QR must equal 0. So let's find PQ. P to Q is equal to KB. AQ is equal to KB. PQ is equal to A minus K of A plus K of B. So this is equal to A outside of 1 minus K plus K of B and then Q of R is going to equal B minus, so B outside of 1 minus K plus K of A. So then when I do the dot product of this, and PQ, QR, and then 1K of 1 minus K plus K of 1 minus K oh no, this is minus K of A. Instead we're going down. So we actually minus K of 1 minus K plus K of 1 minus K, which is equal to 0. Therefore, P, or the angle of PQR is equal to 90. There's cosine of 90 equals 0. Okay. PQA is not going down negative A. Okay. Suppose that now in the square, see that OA is 10 and point P is moving away from the origin at a speed of 0.2 centimeters per second. I'm moving at the same speed along their respective sides. Q, R, and S are also moving. Okay. Their respective sides. X, determine the rate at which the school area of PQRS is changing. Okay, so area is equal to, so OA is 10. Moving the origin is speed. So this is L. So L will be equal to squared plus 100 minus 20k plus k squared 2k squared minus 20k plus 100. So the area is L squared. The area of OA BC oh wait, x is the distance O to P. Oh wait, they already never mind. OP. So this is x already. That's me. So this would be x minus 20x plus x squared. So 2x squared minus 20x. Area OABC is equal to L squared. So this will be 2x squared minus 20x plus 100. Determine the rate at which the area PQRS is changing. X is equal to 3 centimeters. So then the ADX, oh no, I want the A dt is going to equal, let's say, the ADX and the x dt. So then the ADX is equal to 4x minus 20. So the ADT, let's say at x is equal to 3. So what's the rate at which, so the area with respect to time. So the ADT is going to equal, it's going to be 120, sorry no, 12, geez, 12 minus 20, so negative 8, outside of 0.2. This would be negative 1.6 centimeters squared per second. Alright, 20. Sketch of f of x is shown below. Consider the equation located in a constant. Real solutions for f of x. Sketch the graph. Number of real solutions to the equation f of x is equal to k. So my f of x is going to be like this. Maybe I draw in blue just so it's read it properly. Okay. K, and I want a number with respect to k. So let's get some nice obvious ones out of the way. When k is 0, I'm going to have 2. So boom. And then when it's negative, when it's anything less than 0, I'm going to have 0. 0. I'm going to have an open hole there. So it goes up instantly. And it has 2 solutions. Only for there. So anything above it is going to have 4. So 2 is the last point, it has 4. Something like that. And then if it's anything above 2 is back to 2. Sketch a graph. So n of k is equal to 0, given that k is less than 0, it's going to be 2, given that k is equal to 0, or k is greater than 2, and it'll be 4, given that 0 is less than k, which is less than or equal to 2. Oh wait, no, because 2 we're going to have 3. Yeah, 2 we're only going to have 3, never mind. 2 would be like... So open hole there as well. 3, and open hole. Okay. So 3, given that k is equal to 3, and then 4, given that k, wait no, it's 2, k is greater than 2. K is any real constant. Define angle of k. Oh wait, it didn't actually need me. So number of real solutions to the equation. Okay, so if you have less than 0, you're going to have 0 solutions. You're going to have 2 solutions if you are either equal to 0. So if you are here equal to 0 or more than 2, you're going to have 3 when you are equal to 2, and then 4 for everywhere between 0, 4 for k is between 0 less than k less than or equal less than 2. So let's see, when you're 0, you have 2 solutions. If you're between 0 and 2, you're going to have 4. If you are at 2, you're going to have 3. Anything above 2, you'll be 2 solutions. Bless me. Okay. Pretty happy with that. Rewrite this as negative k of a plus e of 1 minus k. Check through everything now. This one has a 1 in front of it. So yeah. So C, M. And M is A on B. M is 1 plus CT of 18. And B is A on M, which will be -0.3. And that. m is just the big guy, so you have 2.4. Function t equals 0. I was right here that the margin of error of this would be 0.2121 times 1.96. And so 0.2121 times 1.96, which is 0.415. Wait. I think we're gonna get a bit off. Four one five seven. 7.08. Oh, 843. I actually had this wrong. I'm gonna do plus the 7.9157. Lots of overlap in that. Enough evidence. Oh, for that. But I'm so tired. I probably should not have been doing this exam right now. Four is 2.5, 1.96. Standard deviation here. Oh wait, no, because I'd have to do 1.5 divided by 12. Oh, that's where I get the 1.25. Okay, never mind. So, go back. This was all fine. So 1.96 times 5 on the square root of 144. Is equal to 0.245. It's still wrong. Okay, I don't know how I might have answered that, but it's much closer. 0.255 plus 745. .96 times 1.5 divided by 144. Oh, before I must have not timed by 1.6 maybe? 1.25. I don't know actually. Okay. Chocolate used for 50 biscuits is less than that. 50. So this is TF from negative infinity to 7.3, 0.2121, 7.5. If the probability that the mean differs by mu by less than 0.2 grams is 90%. I don't know, this considered to be sampled. 2.326 deviations, so 0.2, 2.326 is equal to 0.0860. Divided by answer squared, 4. Okay, there was one up here. Wait, this one is correct, I think. So pi is 90. It's 180. Is that? Oh wait, no, I didn't take into account everything. So it's 180 minus x minus pi minus that. Do this. So pi is equal to 180 minus x minus pi plus theta. So this is pi minus 1. Wait a minute, that's not going to work out. Oh, that. And this would be minus pi minus theta. Yeah, that's on the outside, not on the top of the fraction. All over 2 minus pi plus theta. Minus pi plus theta. So this is going to be plus pi on 2, so 3 pi on 4 minus pi on 2, and theta on 2, minus pi plus theta, so it's going to be theta on 2 minus pi on 4. Example 1 was in calculator 3, I think so. Yeah, okay, that's an argument of u exactly. So w is equal to 2 cis of pi 3. Cis of pi 3 is going to be equal to cis of pi 2 plus some theta, and theta must equal then Oh wait, so 4. 4 must be equal to 4 minus 3, so pi on 12. So then element of 12, and then the inverse argument, or the conjugate is going to be negative, so yep. Minus negative pi 4. Okay, I'm pretty happy with that. Pretty happy. Plus 3 pi on 12 to 12 pi 6. Okay. Alright, I'm pretty happy with everything. So I'm going to stop here and then start marking. See you in a second. So welcome back, guys. I just marked. We got pretty... I think this is like 8% worse than we got before, but I could tell when we were doing it that this was going to be a rough one. 84.5%. I think this is the lowest out of any exam I've done, in any subject. So yeah. We lost a whopping 10 marks in calculator 3 and then 11 marks in calculator assumed. So we got a lot to go through. Starting off here, I needed to justify my answer. I didn't do that, so I lost 3 marks straight away. And then I also lost a mark for my value for A because it had to be 2 because of this horizontal asymptote. Because you would have an x squared on the bottom, and then it would be on ax squared. Yeah, something like that. Very sad. This was a very sad day. So yeah, if it can't equal that, if f of x cannot equal 2, 2 cannot equal ax squared on 2x squared. So then clearly a cannot be 2. Squared minus ab on minus whatever. Yeah, I think I'm gonna have to revise some of my functions bits about how it can't be horizontal asymptotes and stuff like that. So that's something to do work on, and also just justifying answers. Here, my explanation. So this was very smart. I like this, where they say each pair of lines intersect. Oh, sorry, each pair of planes, they will intersect in a line, but these lines are parallel to each other. For example, if we have plane 2 and plane 1, plane 1 and plane 2, which is x plus y plus z equals 4, and then x minus y minus z equals 7, so then equals 5.5, and let's say that like 5.5, then y plus z is going to be equal to negative 1.5. So then let z equal lambda or something like that, then y is equal to negative 1.5 minus lambda. So then the line would be like whatever, blah blah blah, and the same for the other lines, which would be very cool. So that was quite smart, I think. Let me pull it up, because I think I did that slightly wrong actually. But yeah, that's essentially it. The lines will be parallel to each other. So it works for the, I just realized it works for these two, because you have y plus z equal 1. If you have them like this, so this would be x is 3. X is equal to 3, 2x. Not sure, but yeah. So something about the lines being parallel to each other. That's why the lines, so they intersect in a line, but then the lines are parallel, so they don't actually, hit each other. So yeah, going down, the rest of this was pretty good. We lost the full marks here, but I'll quickly go through the rest, and also lost 1 mark here. Okay, so quickly for this one, this is because there'll be 505 groups of this, not 1010. So that was the only thing, so I knocked 1 mark off there. And for up here, So you just use straight from this x equals tan of y, tangent squared of y, and then since you would have this secant squared is 1 plus tan squared of y equals secant squared of y. So you expand that, and you get tan of y. Since y is equal to the inverse tangent, then you can simplify this down to x squared, x over 2 squared, and then you do a simplification and you get that. Which is very cool, I think. So we're going to quickly go over to calculator assumed now and go through that, because there's quite a few missing marks from there too. So yeah. Okay, so we're in calculator assumed now. Let's quickly go through it because I need to eat dinner. Here we lost 2 marks because this was supposed to be an equal, it's not a less than, because it's just part of the array. So yeah. I also lost 2 marks here because this should have been an open dot, and I might have possibly supposed to draw lines there, but I think that would I didn't knock a marker for that, but I'm not supposed to have this section of the array. It's only supposed to be this section, because if it was down here, then this would be the distance, or the what do you call it? This would evaluate to negative square root of 5, which wouldn't be true. So yeah, I think I was thinking about the argument ones, where you can talk about the arguments being equal or equal to pi or whatever, and then yeah, that was not what this was asking. So let's go down. Next mark we lost 1 mark here because I don't know what I was doing over here. That is not the correct one, because it would be negative 25, so negative pi there, so you need to go negative 23 all the way to there. So I just had the wrong arguments, but you only got, I got a mark for rewriting this correctly, 2 marks there, and I think you got a mark for saying that, and then the last mark for saying the final 3 solutions, but I got them wrong, so I lost 1 mark. All of this for 2 marks, by the way, a bit crazy. 1 mark here because it's really silly because it doesn't say in the question to do it in polar form, but in the marking key one in polar form, so this had to go. So you had to add pi onto it to make it positive. But yeah, I mean otherwise it was correct. In fact, it's completely correct within the question, but in the marking key one in polar form, it's really stupid. Here I did a boo-boo because I didn't find the argument of it. Find an argument, I could have done negative pi plus this, the phi, and then make sure that it's positive, or you could have just done from here, or just pi plus phi. So then you get pi plus theta on 2 is pi on 4, should be 3 pi on 4 minus or plus pi on 2, which is definitely between 0 and 2 pi. But yeah, I just kind of forgot it. So yeah, this was correct, not a circle. Here you did need to say at least 305, which I guess is correct because it's less than 0.2 grams. If it's lower, then the standard deviation would go higher and stuff like that, and it wouldn't be less than 0.2 is 90%, so I guess that's why. And then this one you could have just said that the point estimate for the mean is within the YBC one, this confidence interval, or it was like 7.5. I did the confidence intervals comparing that, but I think that's fine as well. This was all done well. Concave down. I could have maybe said concave down. It wasn't explicitly, that point where it talked about concaving down was in the graph, so I'm not exactly sure, but I guess it would be good to add. Here I'm knocking 3 marks off because I didn't actually do the dot product correctly, because we had to do each of these terms individually, say that since that is that, it's going to 0, so then that and that will disappear, and since these are the same, you can change that to a squared and stuff like that to make it 0. But yeah, like that. I think because I was thinking that when you have let's say 2i plus 3j plus I don't know 6i minus 2j, when you take the dot product of these, you just multiply like the coefficients instead of the actual with the I and stuff like that. But I think that's just because the magnitude of them would be the same. It's just one. Oh, okay. But yeah, now I'm gonna make sure to expand all the terms out next time.
Are you coming to Canada tomorrow?
Probably not.
No?
Probably. I mean, I don't know.
Okay.
I don't know right now. Okay, and then sorry, we're back. My brother just came in. But yeah, just make sure you expand all the terms correctly and then have the correct justifications for why. And then, but the rest of this was pretty good. So yeah, I'm not very happy with it. Obviously, the lowest mark we've gotten so far. But it did show what I need to work on, dot products, the function stuff, yeah. Even just some basic reading. I think I was feeling a bit tired, or maybe it was just this exam was making me tired, but yeah. Even stuff like this where I just didn't read, it had to be the argument or just the fine. Yeah. See you guys later.